our second video of our AMC series. In this video, we'll be doing factoring, mean, median, mode, and decomposition. So this is our first topic of factoring. This is basically a tip. It's called casting out nines. When you are trying to find the single digit sum of numbers, you use this. So this is a process of adding up digits of a number. It'll help in factoring. Here's an example. What is the sum of the digits of the number 96,216? So in this trick, you basically take out the nines and all the numbers that make up 9. It's like here, in this case, 6 plus 2 is 8, 8 plus 1 is 9. So you're going to take out 6, 2, and 1. According to this trick, our sum is 6, but we're going to test this out just to make sure it's right. So 9 plus 6 plus 2 plus 1 plus 6. 9 plus 6 is 15, 15 plus 2 is 17, 17 plus 1 is 18, 18 plus 6 is 24. Now, we want the single digit sum for this trick. So you're going to do 2 plus 4, which is equivalent to 6. It's right. If you get no number while doing this process, that means your sum is 9. We're going to test that out too, just to make sure. So 9d9 is this number. 9 plus 9, first of all, no number. 9 plus 9 is 18. 1 plus 8 is 9. So yep, this is a really easy trick you can use for factoring sum. So if you just want to learn more about casting out nines, you can always search it up on reliable sources on the internet. So now we're going to go on to one of my personal favorite tables, the divisibility rules table. So for one, it goes into everything. If the number ends in 0, 2, 4, 6, or 8, it's divisible by 2. If the sum of the digits is 3, 6, or 9, it's divisible by 3. If the last two digits are divisible by 4. If the number ends in 0 or 5, it's divisible by 5. If the number is divisible by 2 and 3, you use both its rules. Then it's divisible by 6. 7, sadly no rules exist. 8, the last 3 digits are divisible by 8, kind of like 4. 9, the sum of the digits is divisible by 9. Use casting out nines. 10, the number ends in 0. 12, the number is divisible by 3 and 4. Like you see, I hope you see something. And then 25, the last 2 digits are divisible by 45. Now we're going to go on to some more problems in factoring. Here's a problem in factoring. The 5-digit number is divisible by 9. What is the remainder? And this number is divided by 8. So for our nines trick from our divisibility table, it says the sum of the digits should be divisible by 9. So what we're going to do, how we're going to find out u. We're going to use our casting out nines trick here, because 8 plus 1 makes 9. So we're going to take out both of those. So 0 really doesn't have anything. So 2 plus u should be divisible by 9. Okay, so the only number u can be then is 7. 2 plus 7 makes 9. You can only have a single digit number. So u is 7. Which means this number is 20,187. So now we're going for 8. Our 8's rule is the last 3 numbers should be divisible by 8. But we know we're going to get a remainder here. So, but it's enough if we divide the last 3 numbers by 8. So that's exactly what we're going to do. 187 divisible divided by 8. So, and then we're going to get 23 remainder 3. So that means that our answer is B. problem in factoring. How many positive factors does 23,232 have? As you can see, I've prime factorized this in the tree method. So basically, we have, So you want to find out how many positive factors there are. If you these are also factors, but if you calculate all these, you're just going to keep going and it's going to be really hard. So instead, there is a formula for number of factors. So what you do is you take the exponents, 6, 1, and 2, 6 plus 1, 6 plus 1 times 1 plus 1 times 2 plus 1. So you take all the exponents, you add 1 to them, and you multiply them. This is just a formula. So in this, what you're going to get is 7 times 2 times 3. So here we see, easiest way I think to do this, 2 times 3, 6, 6 times 7, 42. There's 42 positive factors, which is E. Another problem in factoring. Let Z be a 6-digit positive integer, such as 247,247, whose first 3 digits are the same as its last 3 digits taken in the same order. Which of the following numbers must also be a factor of Z? So Z is basically A, B, C, A, B, C. That's basically what Z is. So here's another thing that's going to help. If you multiply a 3-digit number by 1001, the answer is going to be those 3 digits repeated twice. So basically, 1001 times ABC is equal to this. Okay? Next, we're going to prime factorize 1001. First, 11, 91, this, 7, 13. There we go. So that basically means 11 times 7 times 13 times A, B, C. This is Z. So now we know that Z is divisible by 11, 7, and 13. But as you've only been given one of these 3 options up here, our answer is A11. In case you're a little confused about this 1001 thing, I've drawn up a little thing just to clarify. So we're going to multiply 1001 by the number 246. I've done all the math. I'm not going to go into explaining every single detail. But as you can see, you get 246, 246. You multiply a 3-digit number by 1001. The answer is those 3 digits coming twice. Now another problem in factoring. On June 1st, a group of students is standing in rows with 15 students in each row. On June 2nd, the same group is standing with all of the students in one long row. On June 3rd, the group is standing with 1 student in each row. On June 4th, the same group is standing with 6 students in each row. This process continues through June 12th with a different number of students per row each day. However, on June 13th, they cannot find a new way of organizing the students. What is the smallest possible number of number of students in the group? So first, we know that this number has 12 factors because you're able to organize it in 12 different ways. Now, if you remember, we did this a few problems back. We used our formula for number of factors, which is the exponents plus 1 multiplied. So in this case, 15 and 6 is the known factors. So if you write them out in multiplication, you get 2 times 3 times 5. And now if you just use plug these in this formula, let's see, we have 12 factors. Let's see what we get. 1 plus 1, 1 plus 1, 1 plus 1, 2 times 2 times 2, 4 times 2, we get 8 factors. But we need 12 factors, okay? So one important thing before we go to the next step. You want the smallest possible. You need to remember this is a problem. So we only have 8. That means we need to square one of these numbers. Because we want the smallest possible number, we're going to go ahead and we're going to square 2. So now if we solve this, we're going to get our answer. So 2 times 2, 4, 4 times 3, 12. 12 times 5 is equal to 60. So C is our answer. Just because I squared it, let's make sure one more time that this gives us 12. Okay? 2 plus 1, 1 plus 1, 1 plus 1. 3 times 2 times 2. 3 times 4 is 12, which is same. So that's good. Now here's a fun riddle. Malcolm wants to visit Isabella after school today and knows the street where she lives, but doesn't know her house number. She tells him, my house number has 2 digits, and exactly 3 of the following 4 statements about it are true. So the question they're asking us is, so this information allows Malcolm to determine Isabella's house number. What is its units digit? So this number is 2 digits, so we want to know its last digit. So first one is, we know one, this is false. First one is prime, it is even, it is divisible by 7, one of its digits is 9. I can tell right away that this one is false because it's even and divisible by 7, only one is false, so we know that 1 is false. So next, it is even. We know from our divisibility table that if a number is even, its units digit has to be an even number. So we can tell off here that C is not your answer, E is not your answer either. Next, it is divisible by 7. We can't really tell anything right now. For one of its digits is 9. This is a 2-digit number, and its last digit has to be even. Because 9 is odd, we know that's this digit, so we need to still find out this one. So it is divisible by 7. In this case, the easiest thing to do is to plug in these numbers and find out. 4 and 6 divisible by 7, this one gives a remainder, so we know D8 is our answer. Now on to our next topic, mean, median, and mode. So mean is the average. To find the average, you add all the numbers in the set and divide it by how many numbers are in the set. Here's an example, 3 plus 7 plus 10 plus 16, you get 36. There's 4 numbers, so you divide that by 4, so the average is 9. Median, think middle, so it's like if there's a list of numbers, it should be arranged in order to find the median. The number right in the middle, or the average of the 2 middle numbers. If it's even number of numbers, you're going to have to do average. Odd, you're going to have it. That's the median. Example, 1, 3, 5, 7. The average of 3 and 5 is 4, so yeah. Mode, number in a list that occurs most often. So the number just occurs most often, that comes most often. Like, here's an example. This 16 is the mode. Now a problem, mean, median, and mode. Mr. Garcia asked the members of his health class how many days last week they exercised for at least 30 minutes. The results are summarized in the following bar graph, where the heights of the bar represent the number of students. What was the mean number of days exercised last week, rounded to the nearest hundredth, reported by the students in Mr. Garcia's class? So this is the number of students and the number of days of exercise. So in our mean, the top part is going to be the total number of days exercised over the number of students. Now, we need to multiply these up. Why? Because you see, one student exercised Wednesday, 1. But here, 3 students exercised for 2 days. So there's a total of 6 number of days given. So now, we're going to multiply all of these. This is just 1, 6, 6, 24, 40, 18, and 14. Now, if I add them all up, I'm going to get 109. And now we need over the number of students. If we see here, this is the number of students. 1 student, then 3 students, 4 students, and then 2 students, 6 students, like that. I add them up and I get 25. Now if you divide this, you get 4.36, which is right here. See? Okay, here's another problem. The following bar graph represents the length in letters of the names of 19 people. What is the median length of these names? So we know that there's a total of 19 people, 19. So the median is going to be the 10th one. 19, 9 on each side, median is going to be the 10th one. So as we see here, this is the 7th one, and then we have the 8th one, 9th one, and 10th one. So that's why the median is 4. Because this is the median 4. B. Now, prime decomposition. Prime factorization or integer factorization of a number is breaking a number down into a set of prime numbers which multiply together to result in an original number. This is also known as prime decomposition. We're going to do this problem to help explain prime decomposition a little bit, but this is also our first problem. The sum of 2 prime numbers is 85. What is the product of these two prime numbers? So you should know if you're having an odd number, you have to add 2 numbers to get it. One of these numbers needs to be even. But it's 2 prime numbers. The only even prime is 2 because everything else is divisible by 2. So 2 plus something is 85, and we can tell this is 83. Sorry. Right. So now we know 83 is a prime here. But if you want to make sure, it's going to be helpful in AMC if you know your prime from 1 to 100. It'll save a lot of time so you don't have to check, and it's going to be easier. So the question is, what is the product of these 2 prime numbers? 83 times 2 is 166. So that is E. Now another problem. What is the sum of the prime factors of 2010? As you see, I prime factorized these, and these are the factors. Now we just need the sum. So 67 plus 2 plus 5 plus 3, 5 plus 3, 8, 8 plus 2, 10, 67 plus 10 is equal to 77. Great, you see? Thank you for watching. I hope you enjoyed and learned something from this video. Please come with us next week to watch our video 3, which will be on number theory, permutations, and combinations. Bye!
Don't forget to subscribe and like. If you have any questions, you can email info@agouramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!